What if your Python program can think step by step, adapt to the real world, and take actions like human agent? Well, that's possible. Welcome to the future of AI, where reasoning meets action, powered by LangChain and ReAct algorithm. In this video, we are going to deep dive into one of the most powerful paradigms of building AI agents using Python and LangChain. Well, we will first go through the concepts in a quick visual walkthrough, and then we would do some hands-on. First hands-on would be on simple AI agents that run in a loop, and second hands-on would be interacting with MySQL database. We would write prompts and our agent would interact with the database to give us the relevant information asked by the user. So first let's go through the concepts of ReAct algorithm and LangChain. Let's start with a high-level overview. We are talking about building agents using ReAct algorithm, which stands for reasoning and acting. This approach allows the LLMs to not just think, but to interact with external tools like calculators, search engines, and databases, and reason based on the result. Before we understand ReAct, we need to appreciate chain of thoughts. Chain of thoughts prompting, COT, enables large language models to break problems into logical steps like a human would. Think of it as an internal reasoning before making any decision. So in sequence of steps, we can make the LLM learn how it should logically identify these steps, think, and then react. This is the comparison of standard prompting versus the chain of thought prompting. You can see there is a math problem, and in terms of standard prompting, if we directly give the question, for example, Roger has 5 tennis balls, he buys 2 more cans of tennis balls, each can has 3 tennis balls. How many tennis balls does he have now? The answer is 11. So this is a question answer that the user has provided to the LLM. And next then he asks a new question, a math problem, and lets the LLM think of its own. So in this prompt, the user is not suggesting how the LLM should think about that problem, directly provides the answer. So in this case, you saw that the output given by the LLM agent is wrong. In case of standard prompting, this is the drawback. If we directly put questions and answers, then the LLM agent might not be able to identify the way it should think like a human. Rather, if we try the chain of thought prompting, if we break down the solution in steps and let the LLM understand like a human how it should break a problem, execute small steps, and then find the answer, then that is going to serve a better response from the LLM. So you can see in the chain of thought prompting, if I provide the solution like Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, so 5 plus 6 is 11, then the answer is 11. So this is basically prompting the agent how it should think, break down the problem, and provide the answer. Then if I supply a similar kind of problem, then boom, the agent can now think similarly like a human and provide the solution. So you can see the model output here is much more refined and similar to the way humans should think and respond. So that is the magic of the chain of thought prompting. ReAct takes this one step further. Instead of just reasoning, it allows the model to take actions in between steps. It can say, let me call a tool and then continue reasoning on the tool's response. For example, if I ask something to the agent that it doesn't know, then it can say that I need to look this up in the Google. It searches the web, then it uses the results that it has obtained from that search, and then it again refines the answer and thinks again. It may be iterative and dynamic. So whatever things it doesn't know, it accesses the relevant resources and then refines the output. This is the basic architectural diagram of the ReAct algorithm. The user gives a query to the agent. The first step, the agent thinks on the problem, then parses that thought process, maps that to the tools that is available to it. Now these tools are basically functions that is exposed to the agent. The tools are functions. So based on the description of the function, the agent would identify which tool to call, and then on tool execution, the response result by the tool is the output. Now if that output is sufficient to answer the question asked by the user, the query of the user, then okay, well, I reach to the final answer. But if I don't reach to the final answer, if that output of that tool execution is not sufficient enough to answer that question, then again it runs in a loop, goes to that agent again thinks over, this is my previous tool's output, what tool I again need to invoke so that I get a complete context to answer this question. So again it thinks, and then it parses the response of the thought process, identifies the tool that it needs to execute, executes the tool, gets the response from that tool, then again it correlates, can I give a final answer? If not, then again iterate. So it runs in an iterative dynamic process. So this is the overall ReAct architecture. Now let's talk about the LangChain library, and that's where LangChain comes in. LangChain is a powerful Python framework that lets you create LLM driven applications very easily, because using LLM you have to do a lot of groundwork, and using LangChain we can define tools, wrap them into agents and plug them into OpenAI or other models, all just in a few lines of code. So here, to implement ReAct agents, we have create ReAct agent, a basic function provided by the LangChain. There are other utility methods as well to create ReAct agents, but we would try with create ReAct agent in this demo. Alright, now that we understand the theory, it's time to build something awesome. We will try out two hands-on exercises in this video. The first exercise would be a basic one, how to implement and create ReAct agent and execute the agents with a simple tools. And in the next one, we would try out connecting the tools with the MySQL database so that the user can ask some queries and it would dynamically invoke tools of data from the MySQL database and gives us a final output. We'll try out these two hands-on exercises. So let's proceed with the first hands-on. Let's create a project folder here. Let's say LLM agent POC, and then let me open the command prompt here. We have to first create an environment. So for creating that environment, I would use pip-in. You can use Python virtual environment. Okay, no issues. I would use the pip-in shell to create that pip-in environment. So just make sure that you have the latest Python installed, because the LangChain dependencies might require the latest ones. Once I have created the pip-in shell, you see that pip file has got created, and I am inside a virtual environment of the pip-in. Now let me install all the libraries that I would require. I would require the LangChain, I would require the OpenAI, I would require the Black, I would require the python.env. To read the environment variables from the .env file, I would require the python.env, and then I would require the LangChain OpenAI. LangChain OpenAI. And last but not the least, I should include the MySQL connector for the second POC. So MySQL connector Python would help me to connect with the database. So these are the dependencies that I should require, and I have forgot to mention the install. So it should be pip-in install, then the dependencies name. Well and good. Now the dependencies are getting downloaded and it's getting installed. Let's brew a coffee and let the installations get proceeded. Hey, just taking a quick moment to share something exciting with you all. If you are passionate about learning programming, development, or upskilling your tech career, you have to check our platform onlinestudysmart.com. We are not just another edtech website. Our vision is to empower students from schools and colleges across India with industry-ready tech skills. Our mission? Making expert-led hands-on coding, education accessible, practical, and career-focused. We run live instructor-led programs, including our flagship Java 16-week training designed to take you from zero to job ready, with real-world projects and personal mentorship. We are already helping hundreds of students from schools and colleges unlock their potential with structured guidance and career-aligned courses. And hey, if you love reading, we have also got high-quality blogs on programming, development, and career tips, all crafted to give you real insights and keep you ahead of the curve. Okay, so the installations has been proceeded and it's completed. Let's open the IDE now. I would be using the Pycharm IDE. Okay, so I have imported the project in the Pycharm IDE. Now let's create a simple file like main.py. So in the first POC, we would have tools as functions, and those two functions would be finding some attributes from a string, maybe finding the length of the string or finding the number of vowels, and then I can use the agentic framework from LangChain utilizing the OpenAI to dynamically find which method it should execute. Let's do that. First, let me write those methods. First one is to finding the length of a string. So the input would be a text that is a string, and this method returns an integer. Okay, so I have to provide, it's a golden rule that I should provide a description of what this method does. This method returns the length of a text. This method returns the length of a text by characters. Okay, so this is what this method does, and let me give a print statement to see what I have got as an input. So let me see that the method has received this text just for logging purpose, has received. So I can provide the text here that I have received as a parameter. Okay. Okay, fine. Now I would just chunk out all the irrelevant \n kind of stuff that generally comes during dynamic processing by the LLM. So I need to do this, but you can skip this right now because it's not so much relevant to you right now. But as I use a lot of LLMs and I know this problem that it occurs, there might be some double quotation or \n characters that is not desired. So I need to strip them out. Okay, so then I would return simply the length of the string, return length of the text, right? So this is the first method. Now I would use the decorator @tool from the LangChain. So import LangChain dot tools for import from LangChain tools import tools. Now I would create another tool. There is a simple method that finds the vowels from a string. So get vowels from text, it will return the number of vowels. Get number of vowels, right? This is my method name. And similarly, I have to put the description in such a way that it should reflect what it's doing. It's very important because the agent would read from this description. So returns the number of vowels, number of vowels present in that string, present in that text, okay, by okay. So received what I am receiving as a tool, I should put that in the log. Now my task would be to find the vowels. So for that I am writing a very vanilla basic code. In the list I would store all the vowels. And the uppercase ones as well. A, E, I, O, U, right? All the vowels are stored together. Now I would iterate on the characters present in that string, and then I would count if CH in B, then I would count C equals to C plus 1. Now this C would be equals to 0. Now I should return that C, right? So this method takes an input as a string and then it returns the number of vowels present in that string. So my two tools are ready. These tools are as a function that I would expose to that agent. Now the agent would be able to consume these two and then give me an answer based on that. So before that I need to create a list of the tools present. So tools equals to, in a list, what is the first tool? The first tool is that get text length, and the second tool is the get number of vowels from the text. So I have created a list of tools, right? Fine. Now my task would be to create the LLM object. Let's use the OpenAI. Okay. OpenAI object. So let me import this one from LangChain OpenAI, and I set the temperature to 0 because I don't want the LLM to be innovative and creating different variety of answers. It would think out of the box and try to hallucinate. So I don't need that. I don't need the temperature. Okay, fine. So before proceeding to that, I have to set the API key. Now to have the OpenAI key, you have to. So before using the chat OpenAI object, I should have an OpenAI key. So I have to keep that OpenAI key here. So for that I have to go to the OpenAI website and create a subscription. So I have an account. I would create a new secret key. Okay. And it would provide me a key. You can go sign up in the OpenAI and you have to put some credits over there with your debit card or credit card. Put some minimum $5, or I think that is the minimum that you have to put, and then you use that key, pay as you go. It would cut some tokens. Then you have to put a $5 or something, and then as you use it, the amount gets deducted from that balance. Okay, so I have to put that key here in order to proceed. So OpenAI API key, equals to this one. I would delete that key once I am done with this POC. I would delete this key. No worries, if you're copying it, you would get that. You have to create your own. So my LLM object has been created, and internally it would use that OpenAI key that I just put in the .env. And in order to use that, I need to load the env from the .env file. For that, I have to use the load.env method provided. Okay, so that would automatically load. It's a spelling mistake, sorry. It will automatically load the env from the .env file. Okay, well and good. Let's proceed. So I have created a chat OpenAI, and then I am going to create that template of the prompt. So the agent would get a prompt put to it. So that prompt is a very unique one. The prompt is the key here. So it's a very unique. You see how the prompt looks like. This is from Harrison Chase's a sample prompt for the ReAct one. So I would use this one, and then I would explain what does this mean. So answer the following questions as best as you can, and then you have to access to the following tools. Now these tools would be replaced by the list of tools that I have in hand. Then you use the following format. So here I am instructing the agent to think like this. The LLM would think like that, rather to say the LLM, because the LLM would think like this, and in sequence the LLM would get called repetitively and it becomes an agent. So first one is the question, the input question that you must answer. Then you have to think that, put your thoughts here. You should always think about what to do. Then you have to identify what action you need to take based on the tools provided, that is the tool names that I would provide. And then once you have identified what action you have to take, then you have to also find out what action input, the parameter you need to send to those tools. What you need to send, what parameter you need to send to that tool, that you have to find out. That is the action input. Once you have sent, then on invoking that tool, you would receive that output, right, after tool execution. So that is the observation, the result of that action. Now this would go or repeat n times. It can repeat n times, that I am also explicitly mentioning. Then upon reflecting, when I reach the final answer, then I should say that the final answer to the original question is this one. Okay. Now you begin. I have provided the instructions and you begin. Question, I have the input placeholder. I would replace that with the user input, the prompt that the user would provide as input in the beginning. And then this is this agent sketchpad. Now this agent sketchpad is the history of the interactions the LLM is doing. In the first iteration, the LLM would find out the thought, action input and observation. Now all those history, I would put that in that agent sketchpad. Suppose I have run this loop 3 times. So I would have 3 sets of thought, action input sets. Those set I can provide inside that agent sketchpad. It would become our reference to the LLM so that it doesn't take duplicate steps. Okay, so that is the importance of this sketchpad. Now once that prompt template has been defined, now I have to replace those placeholders, right? So let's do that. Let's create that prompt after replacing those placeholders. So I would create a prompt template from .prompt. I have to import the prompt template from the LangChain. Now from template, now I would provide the template equals to the template that I have just written, and then .partial, and in the partial I would provide the tools equals to, now the whatever tools I have, they are functions. with decorator@tools. I need to provide a list of the method name and the description. In order to do that, the LangChain provides me with a utility function, that is the render text description, that would automatically do this task under the hood. Render text description of the tools that I have. It will automatically fetch and generate the text description from that tools, method tools. I have to provide the tool names, right? Because see, here I have two placeholders. One is the tools, and the tool names. So it's partial because the other placeholders I am not addressing here. So it's partial, dot partial. Now tool names equals to would be the comma separated name of the tools, right? So let me do that with join. So comma dot join. I would like to join the list of the tool name from 40 in tools. Okay. 40 in tools, t.name, I would join that with comma. So then good, fine. Okay. So our prompt template has been created, right? Now next is to create the agent. Now here is the magic. I would use the create ReAct agent method. Create ReAct agent, and then I would supply the tools equals to the tools I have, list of tools I have, and then I will also provide the LLM. I am using a chat OpenAI object LLM, and I would provide the prompt, the ReAct prompt that just we have framed. Okay, so this is the agent object that we are going to create. Let's import that as well. Create ReAct agent from LangChain. Now the agent has got created, and now we would execute that. So agent executor equals to, we have to use that agent executor from LangChain again, and we have to pass the agent equals to the agent that we just have created, and we also need the tools equals to the tools that we have. We also need to pass some fields like the handle, parsing errors, and verbose. Let's do that. Handle parsing errors equals to true, and then we have to put the verbose equals to true, and we also need to put max iterations. So this is running in a loop, right? So this loop, I can limit that using the max iterations if we want. I can limit that to 5 iterations maybe, because I know that this process should not take more than 5 iterations. It's very small operation, right? Max iterations I can put as a parameter. Okay, well and good. Now this executor has been created. Now I have to invoke that, right, with an input. So I would invoke that. Let's create an input question. So input equals to, let's make it a very simple. What is the length of string Hiranmoy? That's my name. So I am asking the agent to find what is the length of the string Hiranmoy. Let's see how it does. it would be consumed by the agent. It would think on which tools to use among the tools that I have provided, the get text length or the get number of vowels. Among these methods, automatically the agent would pick that up. So I have created the input. Now my work would be to invoke that agent executor. So agent executor dot invoke. I would invoke that with the input as the one that I have just created as input. Okay, so I have provided that. Now let's run this one and see how the agent picks up the tools and run. So I've started the main.py, so it's entering to the agent executor. 1 answer 3. Okay. So I was not getting the correct output from the agent, so I made some tweaks to the prompt. So this is what prompt engineering looks like. You have to fine tune the prompt and you have to tune it in such a way that it provides you the correct answer. It doesn't hallucinate. So I have provided this line: once you reach the final answer, stop this process, because I saw that it was hallucinating on unrelevant questions. Do not hallucinate on the questions, think on the question that the user provides. Let me run it. When I run this, I get somewhat the correct output. So the agent executor chain has started. So it is thinking that I need to find the length of the text. What action I need to perform? I need to perform the get text length. My input to that function would be okay. So this log is printed from the tool, which on invocation I have printed this one. If you remember, in that method I have printed this one. So this is that print, and all the green ones are from the internal logging of the agent executor provided by LangChain. Now I know the final answer: invalid format, missing action. Again it's thinking, what is the length of what I need to perform. Then it says that I need to find the length. I have to find this action input, this one. Then it has got the observation that it's 8. Now I know the final answer. The final answer is 8. So this is how the agent is working. In the background it is trying to find the tool and it executes that to get the final output. Now I change the question to find what is the number of vowels in Hiranwan. What is the number of vowels in Hiranwan? Then let's see how the agent responds. It should pick up the other tool. Let's see. The agent executor has started, and see, I need to find out the number of vowels. I am executing this method, get number of vowels from text. The input is Hiranwan, and then I have found the output as final answer is 3. So it has correctly pulled out and invoked the correct tool and obtained the answer for me. Out of numerous tools, it is able to pick up the tool that it should invoke, and then I get to see the output here. So this was our first POC on simple tools. Now we would create the connection with the database. The second POC, I would require some methods, the tools for connecting to the database and running some queries, and that I would expose to the agent, and the agent would perform likewise. Let's do that. So I would just copy this code to our new main. Before that, I should create a SQL tools that I would use to create the tools. In this file, I would copy those tools. Okay, so now I would create the SQL tools. Let me put the code and explain you. So I have created a connector from the MySQL connector. I would connect to the database hosted in localhost. So I have to spin up the MySQL server here. I provided the user, the password, the database name, and then I'm exposing some functions to interact with the database. Suppose the table that I have in the student table inside the school DB, the table has these parameters. For example, this one. So let me create the database first and then explain you the code. That would be easier to understand. Now let me spin up the database MySQL localhost server. It would take few minutes. Hold on please. So I would just spin up the database. Database is up and running on port 3306. That's fine. Now I would open that MySQL the terminal from where I would run the comments. Okay, I am inside there. So let me see whatever databases I have. If I have the student DB, then I would drop that and create a new one for you so that you get an overview how I have created and linked that to the project. The database, then the database. Okay, fine. Now I don't have the student DB. Now let me create the database. Create database, student DB. So before running the code, I should have the database up and running. Now I have to create the tables, right? I should have this table on which I am trying to operate. Suppose I have a table. That table has a name, a registration number, that is the primary key, a total, a percentage, and the class of the student. So this is my table schema. Let me create that table first. Create table name is student. So I have name, that is a varchar of 50 size. Then I have the registration number, that is of integer, and it's a primary key. And then I have a class, there is an integer as well. And what do I have again? Percentage and total. Percentage of the student, okay, and total. Let me provide that total as well. Okay, so this is a very simple schema. Table has got created. Now I would put some data into that table. Let me provide data. So I have data for few classes because I would test that with different classes, maybe with class 8, class 9. So I have created the data for different set of students. So this is for class 8, and let me put some data for class 9 and for class 10 as well. Okay, so I have data, lots of data, right? So select start from the student. Let me see how the data looks like. So I have lots of data in that database, and I would now run my program to see. Now going back to the program that I have, so I would now create that table that I just created using this connector from the MySQL, and I'm exposing some functions. Use that @ tool decorator to find the name percentage. What this function does, takes the registration number as input, and then it finds out the name and percentage of the student if found. So if the connection is okay, if the database connection is up and running, it's not null, then I would first create a cursor object, then I would frame that query. So this query is going to get executed via this tool. Select name percentage from student where registration number equals to, that is provided by the user as a parameter to that tool. Now when I execute this query with that registration number that I have in the param, I fetch the result that I get. I would find out the name and percentage from that result and print that as a form of string. So what is the output of this method as a tool? It returns me the name equals to that name, percentage equals to the percentage of the student. Otherwise I would return, oops, the student is not found. Okay. I have also try catch handling in order to handle any kind of SQL errors. Okay, so that was the first tool that takes a registration number as input and finds the name and percentage as the output. So if I provide any registration number among these, I can get a relevant output from the table and I would get the result. Let's see during running that. Now I have this another tool that would find the average of the total of a particular class. Suppose I put that class here is class 8 or class 9. Then I can find the average of all the totals of the class 8 students. If I have class 8, then in class 8, whoever is studying, all the totals what I have in that class, I would sum up and then do the average. And that would be done by the SQL query. So I want to see how far that the students have performed in that particular class. So that is finding the average of the total of the students in a particular class. I take the class ID as input, then I create a cursor object, I execute this query. Select the average of the total column from the student table where the class equals to the ID that has been provided by the parameter. So this tool is clearly mentioned in the description. It takes the student class as an integer and returns the average of the tools of all the students in the class. So this method returns us the average of the totals of all the students in the class, right? Now, if the average total that is found, then I would return as a string, a text output. Average of the class is, this is the average total, right? So this is the second tool. Now I have the third tool. Suppose I have the class average and I need to find the grade of the performance of that class. So this tool I have introduced because I want to show you that the LLM agent can sequentially find out what tool next it should pick up. The first tool it might need to pick up, if I ask it to find out the average of the total of a particular class, then it would pick up that average finding tool. Now suppose I want to ask it what is the grade of that performance of that particular class. Then first it would find the average in the first step and then it would find out the grade of performance of that particular class, right? The first tool executed is the second one, this one, and then it would use that output, this one, it would use that output from this method tool and then it would plug that to the third tool, this one, and find us the grade of that class performance. So this is a method that takes the average of the total of a class as a float input and finds the grade of the class performance. It would find us the grade of the class performance. Now let's see how we plug that to that agent. So for that I am just making another file, main2 or main with SQL tools rather. Now let me copy this one and I would remove those tools because I have now new set of tools, right? I don't need these tools. Now instead of this I would use the tools that I just created, this one, and the first one was finding name and percentage. Now I have just need to import those tools from that particular utility class, the file that I have provided. Now I just need to import that. I have imported those methods, right? Now the tools has been provided. I have provided the prompt, same ReAct prompt would work. Now I just need to change the question. Now I have the question, what is the name and percentage of the student with registration number 1001? Let's try to run and see what is the output, how the agent works and things. Okay, so it has identified what action it needs to perform. The action is the find name and percentage method, and output is 1001. So these things are coming because I have put print statements just to debug and find what was the actual issue. It turned out to be some hallucinating problems with the AI agents. Okay. So see, finally that name of the student or the percentage has appeared, right? Now if I query that in the DB, let me validate whether that is correct or not. Okay. That should be validated, right? Because I need to see whether it's working fine or not. Yeah. So registration number 1001 is of Arab Sharma, who has secured a percentage of 96. That's correct. Now let's try with another query from the user. Let's say find the average of total of class 9. Let's find the average of the total of class 9. For this case, which method should get invoked? This one. You are correct, this one. Let's see whether the LLM is correct or not, the agent is correct or not. Let's try that out. I'm running with the new input to that agent executor. So it has identified that find average of total, this method it should get executed. The average of class 9 is 85.6. I know the final answer. Then it's again trying to evaluate the 9. Now it has found out the real average of the class. It's 443.333. Let's try out that query in the MySQL window and see whether it is correct or not. So for class 9, I want to check what is the average of the totals. Let's see. Whether the LLM has given correct answer or not. So it was of class 9, right? Let's see. Yeah, see the class 9 average is 443.23. So the LLM is correct here. Again, the second one has passed. Now let's try with another query. What is the grade of the performance of class? What is the grade of class 9? Let's say. Whenever it sees a grade of something, it would identify. Here would be the magic. I want to see whether it takes up the first step as the find average of total, and then it runs the grade the class based on average. Because if I don't identify what are the list of tools I need to execute, then it is a problem, right? Now let's see how the LLM works in the background. So I have the query, what is the grade of class 9, and let's see what it does. So it has executed the first by the average of total. Yeah, fine. It has found out the average, and then it has found out the grade of class 9 is B, right? So it has executed the second method as well and find out the average, find out the grade. Okay, 443, I think it's correct because greater than 400 would be B plus. So it's a B plus, it has said B. It's a little bit different. Now let's try out with modifying the prompt and let's see what is the grade of average of totals. We have to make it align with the description. That's why I was telling that you have to make the description very accurate. Takes the average of the total and finds the grade of the class performance. We should use this term. Let's see how it performs. Find the grade. What is the grade of class performance of class 9? Let's see how it operates with this prompt. Let's see, now it has performed. The first step was find average of the total. It has found the average. Then it is identifying that the class performance needs to be identified based on the average total of class 9. So the next action is grade the class based on average, and then input is this one and the output is B plus. Now it has identified the grade of the class, performance of the class 9 is B plus. Well, so this was about the agents orchestration with SQL tools. Now the problems which I saw is a bit of hallucination works whenever there are some differences with the prompt and the descriptions of the tools. So this is a kind of black box that the LangChain has provided us, and it's operating in the background and we don't have anything at our disposal, and we don't have the control to stop the flow of the execution of the agents, of the tools rather. We don't have the control. It's a black box, it's running in the background, and LangChain is doing the task for us. One advantage is that you don't need to have the complexity or the logic behind the orchestration of the tools. But there is a drawback. Like this, we are encountering hallucinations while execution of the agents. Like you saw that we are getting outputs even after we got the final answer. So for this, what we need to implement the agent executor from scratch. In the next video, I am going to implement the agent executor from scratch, and I would show you how you can create your own agent executor taking help from LangChain framework, but not directly relying upon the LangChain framework for doing everything. You have your own control on the tools and orchestration logic. That I would show in the next video. For now, this is for the day. Let's call it a day. And if you haven't subscribed the channel, subscribe the channel now. Share this video with your friends or your college friends group, and share how you guys can implement LangChain AI agents from scratch. Let's call it a day. Meet you in the next video.